The computer is a tool, it's a fundamental tool, as like a telescope for an astronomer to see the universe. He knows typically what he wants to see in the universe, and he uses his telescope in such way. We use the computer.
In order to locate the universe, you need to have a big memory, a big computing power, and you need to have a lot of I/O for storing the result. This is why this is a kind of simulation that has been performed by Jean-Michel and my team, and this is the first time ever we are able to locate the entire universe inside a machine like CURIE.
My research concerns the issue in cosmology, the origin, the evolution, and the structure of the universe. We need to perform numerical simulation with very high spatial resolution to follow the formation of big structure in the universe. We cannot do analytically. We need a computer.
HPC started as a tool for simulation in large-scale research. Nowadays, with the democratization of HPC, this simulation can be used for competitiveness of smaller scale research as well as in industry like in automotive, aerospace, energy and many other industries. The CURIE supercomputer at GENCI, which is actually based on Xeon processor E5 family, is amongst the top 10 of the world's most powerful computers.
CURIE is a 2 petaflop system built by Bull, and is powered by more than 92,000 Xeon E5 cores. One of the main challenges for us was to build a powerful and balanced system in order to drive world-class simulation like in climate research, in engineering, in life science, and also performing massive simulation in cosmology. As an example, in life science application, we have been able with the Xeon E5 to achieve almost 40% of the peak performance and more than 3 times the performance improvement regarding the previous generation of Intel Xeon processors.
The Xeon processor E5 family actually gives you up to 70% on real-world HPC applications over previous generations. With GENCI specializing in high-performance computing and our profound knowledge and technology in that area, the collaboration has been a very successful one.
Intel has been one of the most important technology providers for us. With CURIE, we wanted to deploy an x86 architecture, and the choice of Intel has been obvious because of the power consumption and the performance of the Xeon E5 processor.
Including Bull's hybrid and fat compute nodes, CURIE is equipped today with more than 12,000 Intel Xeon processors. Thanks to a close collaboration between Bull and Intel's lab, we are able to design our Bull's products to get the best of the Intel Xeon processor E5 family at an early stage, and it have allowed us to make CURIE the most balanced supercomputer in Europe.
For performing this simulation, we need typically all the power of the supercomputer CURIE, 300 terabytes of memory for 10 million computing hours, because it was the largest simulation in cosmology ever run. And we generate more than 50 petabytes of data, and now we have many scientific projects to analyze this data and to answer maybe to the question of the nature of the dark energy and the origin of the structure in the universe.
I think it's one of the most demanding benchmark we ever run, really. So we expect a lot of very amazing achievement by this simulation, and we hope that the team of Jean-Michel Limy is going to really perform a major breakthrough. That's why CURIE is done, for performing major breakthrough. It's not for performing top 500 rankings, it's for performing real science and breakthrough.